Hey everyone, this is Andy Melbuff, and in this video we're going to explore how we can use digital algebra tiles in Desmos Classroom to help student understanding, and also how to create some simple activities using these digital tiles. Before we dive into those, why even use algebra tiles? Well, algebra tiles in mathematics can help make abstract concepts a little more concrete for students and can also help us reach all learners regardless of their level. To begin with, we're going to look at a slide here in Desmos Classroom where we use algebra tiles to help students solve one-step equations. And the one-step equation we're going to solve here is 4x equals 8, fairly simple one to work with. And I put onto this screen a Polypad, and we'll explore how to build this along together in a few moments. But this is already set up for students, and this is student preview mode. So what we have on the left-hand side here of the equation is a representation of 4 x's. And I already have a vertical line drawn here to represent basically our equal sign. So we have a left hand and a right-hand side, if you will. On the right-hand side of our equal sign and our dividing line, I have put in here 8 different blocks of 1 to represent the number 8. And what we're going to do is show how students can use manipulation here of these tiles to solve for x. So starting on the left-hand side, what we want to do in this type of situation is, I don't want 4 of these x's all together. I want individually to have 1x by itself. So we're going to separate these a little bit. Now you'll notice these tiles are all movable. They're draggable. And you could separate them a little bit. They don't have to be perfectly spaced, but that's up to you if you want to do that. So what we want to do is tell students what we do to one side of an equation, we must do to the other side. So I separated this 4x into 4 parts. I need to separate this 8 also into 4 parts. So students would be encouraged to drag these numbers and separate them into 4 groupings. Now, if students do this incorrectly, they'll find when they drag them like so, that all the groupings here aren't the same. So that's a visual aid to tell them something's not right. So this second grouping here has 3 1s and the bottom one's short a number, so they can simply drag another one down here. So what we're asking students to do is visually see that 1x is equal to 2 of these 1s, or 1x is equal to 2, and that's the case in each of these 4 different situations here. So this is a fairly short example of how we can use visual manipulation with the algebra tiles to help students see that x equals 2 when 4x equals 8. Advancing forward, we can also use these tiles to help us with two-step equations. Here, this two-step equation we want to solve is 2x plus 3 equals 11. And so as the teacher, I've already populated on the left-hand side of my line a visual representation of what 2x plus 3 is. I've got 2 x's right here, and I've just got 3 1 blocks spaced out there. They don't have to necessarily be together. On the right-hand side of our dividing line, I've got a representation of 11. I have 3, 4, 5, 6, 7. There's 11 1s there. And what we want to do is visualize how we can solve this equation. So mathematically, before we can separate this 2x, we don't want these 3 blocks over here on the left with it. We want to undo that. So a student, once you work them through this, will use the Polypad tiles, and they'll scroll down here to the algebra section. They'll choose algebra tiles, and here are the different tiles that a student can use to add to this visualization. Now what we want to do is undo the fact that we have plus 1, plus 1, plus 1, and we can undo that by using a negative 1. So a student will drag over or just simply click on these, and these 3 negative 1s will appear over here, and I can kind of group them this way. But if I want to add negative 1 3 times to the left-hand side of the equation, I must do the same on the right. So I'm going to do that here, and I'm going to drag these over. Now, a nice feature about the Polypad is the combining of similar terms and like terms, if you will. So once the student has done the same thing to both sides of the equation, watch this nice feature. This -1 can get grouped up with the +1. And when I click out of there, you'll see 0 in gray. It's kind of tough to see, but these two have negated each other. And so what I can do is combine those to show I've canceled out that +3 over here on the left-hand side. And I can do the same thing here. And so the student has done the same thing on both sides of the equation. And now we've got our 2x representation alone, and I can go ahead and separate them as we did on the previous screen. So I separate them like so, and my remaining ones over here, I also want to separate into 2 groups. So if we want to put them right next to each other, this is what it might look like. And those will cover up some of the zeros we just saw. So this is a nice visual representation that 1x, let me just do a little bit of circling here, 1x equals 4. 1x equals 4. So solving this equation, 2x plus 3 equals 11, a student should arrive at x equals 4. So after seeing digital algebra tiles in action in this Polypad, let's go ahead and take a look at how we can build such a screen from scratch for ourselves. So I'm still in preview mode here, so I'm going to exit out of that. And what we have is simply a blank Desmos Classroom screen here. Here are all the components available for us to put on that screen. And at the very bottom is the newest feature they've added to Classroom, which is a full screen component, meaning it's the only thing that can go on this page. It's called a Polypad on the bottom left. So I'm going to click Polypad. And this Polypad has a series of tiles. And there's a bunch of categories, if you will. There's geometry categories, numbers, fractions, etc., along with a blank canvas. So what I want to first do is prepare my canvas for what I'm going to put in here. So let's say I want to have the student solve a 2-step equation. Well, if I want to type the equation in, there's an equation editor down here where this x squared is. So I'll just click that and I'll put my cursor up here. And let's say I wanted to have 3x plus 1 equals 10. And that's my 2-step equation. Now, after typing that in there, I'm going to select the selection tool, and I can go back to that 3x plus 1 equals 10, and I can make it bigger or smaller. Typically, the way it's typed in, to me, I feel that's a little small. So I want to move that up, and also want to make it grow. It's still showing right in the middle of the screen. So I'm going to move it up a little bit more. Okay, now below that, I want to have my dividing line. So down here in this horizontal toolbar where my drawing tools are, I'm going to choose construction tools, and I'm going to pick line. And I'm going to make a vertical line like so. Not sure that's too vertical. Let's see how it looks in preview mode. Okay, that's fairly close. I do want to move back up though a little bit, so I'm going to drag everything up. And I'm just using my mouse cursor here for this. I'm going to make my line a little bit longer. Okay, that's close enough to where we want to be. Then what we want to do is represent 3x. So I'm going to go down here in my tiles to Algebra Tiles, and I want 3 x's. So I can click on this X box 3 times, and it'll put these 3 x's out here. And then I can drag them together to represent 3x. Now, I also have to have a +1 in there. Well, I didn't give myself a whole lot of room, so I can select all 3 of these and just kind of move them over here. And then I have to represent also +1. So I'll click on this orange tile for 1, and now here's 3x plus 1. I also have to have 10 on the opposite side of my dividing line. So I'll click on a bunch of these orange ones, And again, you can line them up side by side to look nice. You can keep them scattered. It's up to you. I've got 6 of them there. I need 4 more. What I can also do with one of these orange blocks selected is just choose the copy feature. And there I added 3 more. I need 1 more. So now I've got a total of 10. Okay, so now that's ready for students. Let's take a look in preview mode. This is what they would see. So now this is all set up in preview mode for students, except my +1 didn't show up there. I think it disappeared. Okay, here's 3x + 1 = 10. And now the student has the ability to do what we just did on the previous screen. Besides using algebra tiles to solve 1- and 2-step equations, we can also use them to multiply algebraic expressions. So here's a screen where we're going to multiply x + 3 times x + 2. Now you'll notice that this right here is in a different position. It's not really in the canvas itself, and I'll show you that in just a minute. For those of you that like to use a little bit of computation layer, I'll show you how that subtitle goes in. So what I've set up here, a couple of lines. These lines I've locked, and you can lock them by choosing the line, selecting more options or more accessible features, and just make it so it cannot move, because I don't want the student to be able to move that line. So what I've created for the students already is a representation of x + 3. Here's the x, and then we're adding to that 3 single-digit numbers afterwards, x + 3. On the vertical side over here on the left, I have x + 2. And so if students are multiplying, we would encourage them to think about whether you want to use the distributive property or multiplying areas. It's up to you how you want to handle this. But this first box is an x, and we're going to multiply it by an x. So an x times an x is going to be an x squared. So students would want to go over here to our tiles, choose Algebra Tiles, and then there's an x squared. And they can slide that right up in there to represent the area if we multiply x times x. Now below that, right here where I'm hovering my cursor, this here is going to be the result of 1 times x. So we would ask students to think, what's 1 times x? It's x, so they'll choose an x tile, and they'll drag it down here. Then we want to do the same right below that. In this space right here, I'm going to have the result of 1 times x, which is another x. So I select another x tile, snap it in there. And the Polypad is set up nicely so that when you get things close to being where you want it exactly, it snaps into place. I want to also fill in these open spaces over here. So I'm going to have here 1 times x, which is an x. Now if I choose this x, that doesn't fit properly. I can choose to turn it, or I can just use the vertical x tile over here on the left. So if I choose the vertical tile, this fits in well right here, and I'm going to have another 1x and another 1x. So I'm going to grab 2 more of those and snap those into place. And now I don't have any more room to the right of this, so I need to go down to this open space. And what's going to go right here where my cursor is pointing is the result of 1 times 1, which is a number 1. And I'm going to repeat that 5 more times. And I'm going to fill these in. And again, you can just use the copy feature if you don't want to drag them from the menu. And this is a nice visualization. Let me grab a drawing tool here. This is a nice visualization. Inside here is the result of x + 3 times x plus 2. And students can then combine their like terms by really looking at colors. So the students should be able to see that there is a 1x squared box. They can type that in using the math editor. There are 3 green X boxes here and 2 green X boxes here. So that's 5 X boxes. And then lastly, they count the orange number ones, and there's 6 of those. So we would use this as a way to represent x plus 3 times x plus 2 equals x squared plus 5x plus 6. On this next screen, working in reversal of what we just did, instead of multiplying, we're going to use Algebra Tiles to help visualize factoring. So here our factoring that we're going to do involves the expression x squared plus 3x plus 2. And I've already prepped this screen. I've got 2 lines, one horizontal, one vertical, to represent what we just had, the little t-table. And I've already put inside of that what I want the students to factor. Here's an x squared in blue, and then I have 3 x terms along with 2 units. And if this is factorable, this should be square. So students working through this would want to access their Algebra Tiles and would want to ask themselves, what goes here to multiply, what goes here to give us an x squared? So we'd want them to represent that with an x times an x, and notice I chose one that's vertical and one's horizontal, and this perfectly snaps into place to show us that x times x is x squared. Then up here on the upper right portion, I've got to fill in something here that's going to be the result of this 1 times what is going to give us this x. So I'm going to need a 1 there. I'm going to need another 1 next to it. And then I have to fill in this spot down here. What should go here so that when I multiply by x up here, I get an x on the bottom? And that's going to be another 1. So once this is square and filled in and complete, this represents on the left-hand side x plus 1. Across the top, this represents x plus 2. Those are the linear factors of the expression that we needed to factor. And so again, we can use, and here's a way you can change colors if you want. With your drawing tools, we could have students use this to justify that the factorization of x squared plus 3x plus 2 is x plus 1 times x plus 2. Now before we go to our last screen and build along, I want to talk to you a little bit about what I mentioned a few moments ago, the subtitle, which is kind of this line right here. I'm going to exit out of preview mode. And here's the computation layer for the screen. Polypad only has this just for the main screen here if you're using Polypad. So a subtitle is a sync. So if you're familiar with computation layer and want to use this, great. If you're not, just type it in on the canvas as you would normally. The subtitle I chose to use is this. Notice it's enclosed in quotation marks, and anything that I want to look mathematical, for example, my expression, I enclose in backticks. Backticks say that what's inside is going to be considered LaTeX, which is the special math formatting that we math teachers like to use. So the last thing we're going to do is just another build along here where we put one of these slides together. This is a blank screen. The only title I've given it is build along. Well, let's say I want to use the subtitle feature. So I'm going to go over here to the computation layer script for this screen, and I'm going to use subtitle. I'll use quotation marks. And if I want mathematical notation, I'll enclose in backticks, which is basically a reverse apostrophe. It's just to the left of the numeral 1 on your keyboard. And I can type in what I want mathematically to show. I have a closing backtick mark. and then I finish with a quotation mark. My warning symbol goes away, and if you want to do a quick preview, this is what your subtitle will show. Now, to set it up in here, I'm going to again choose a Polypad, which is full screen. In preview mode, my subtitle still shows right up here. So in this, I want to have a couple of lines. So I'm going to choose Construction Tool, Line, and I'll make a vertical one as best I can. I'll make a horizontal one as best I can. And if you don't want those lines to be movable, select your Move tool, select the line, go down here to the gear, and choose Cannot Move. Now those will be locked in place. Students cannot move those. Now if you want to have them work completely on their own with this, you could just leave it as is. And the students then in preview mode would have to go down and grab their tiles to use for this. So maybe they wanted to go with this, etc., and then they can add their ones after that. Now, if we have an x plus 4, I need to have 4 units, so probably that should go horizontally here. If you're creating this for them, you might want to put in your own tiles. And it'll snap in there. Here are my x's that I need, and I need a plus 4 and a plus 3. There's x plus 4 along the top. And along the bottom. Now, if you're like me, you realize, oh, I didn't make this line long enough. You can still drag it down if you're in edit mode right here. And now the screen is all set up for students to do their multiplying. Okay, hope that's helpful. Thanks, everyone.